The purpose of the chi-squared test is to measure the correlation of two variables in order to determine whether they are independent or dependent. It is used most frequently when working with statistics. It can determine if the two variables are related or not, but it cannot determine whether the variables are related via correlation or causation if they are related. That requires further research and investigations that we're not going to talk about in this video today. So if the chi-squared value is larger than the critical value, the null hypothesis, meaning that the two variables are not related, is void, meaning that the variables are not independent and are in fact dependent, or there's some sort of relationship between the two variables. The null hypothesis is also void if the p-value is larger than the significance value.
Chi-square was first introduced in 1900 by Karl Pearson. When he first introduced this new process, it became a new subject of debate. The process he used was less than straightforward and didn't withstand the technical advances of the time. Years later, a guy with the name of Fisher made a correction to Pearson's test. He took in consideration the unknown values that Pearson didn't. Years after that, another correction was applied by a guy whose last name was Yates, who applied a new assumption that Fisher didn't make, and this was proved to be not correct. The last correction was made by two guys whose last names were Kohler and Lawrence, who suggested the use of three categories if the number of observations was less than 10. This was the final correction made to the test. After this was done, the chi-squared test would be used in all fields of research.
In order to calculate the chi-squared test, first you need to put all of your values that you have in the observed value frequency table. So you just write them down in a frequency table based on the two variables, which would be the labels for the columns and the rows respectively. Now once you have that, you calculate the expected value for every single observed value using the formula row total times column total over total total, or overall total, however you want to think of that. But you do that for every single observed value to get the corresponding expected value. And once you have your expected values all calculated, you can go on and calculate the chi-squared for each value. And the formula for chi-squared can be calculated using this formula: observed values minus expected values squared divided by expected value. And that gives you your chi-squared value. And the other thing you need to know how to calculate for the chi-squared test is degrees of freedom, because sometimes that is asked for on a test and it can be helpful in doing some other math related to the chi-squared. So the degrees of freedom is calculated by multiplying the number of columns minus 1 times the number of rows minus 1. So for example, if you had 3 columns and 2 rows, it would be 2 times 1 and not 3 times 2. So you have to be really careful with that, but it's pretty simple. And that's pretty much all the calculations you need for the chi-squared test.
So for the calculating portion for the chi-squared test, you will need a graphing calculator, preferably a TI-83 or TI-84. So you start off and press second matrix, and the matrix is where the symbol is an X with the -1 exponent. And you'll see that there are several different little sections you can go to, and click over to edit, and then enter, and then there you'll see there's matrix A. You click in and type in your rows versus columns. Now, do not input any totals into it, only the data. So type in all of your input, then click Stat, and you'll see other sections where you have Edit, Calc, and Test. Then click over to Test, and then go all the way down till you see the chi-squared symbol. And that's at the letter C, and the chi-squared symbol is, the x squared. So click Enter. You have to click Enter at least 3 times to get to Enter over Calculate. And then you have your chi-squared, your p-value, and your degrees of freedom.